Okay, so here you can see a parabola, and in this video I will try my best to explain the different parts of a parabola and how they relate to each other. Okay, so let's start by naming the equation of this parabola. This is x squared equals 8y. So two things we need to remember. Number one, if the one with the square is the variable x, the parabola opens upward or downward. This one opens upward because obviously here on the right side we have a positive 8y. If that's positive, the parabola opens upward, and if it's downward, the 8y, or that side of the equation, is negative. And by the way, here as you can see, our um, vertex is at 0, 0. Okay, so in general, this parabola can be expressed as x squared equals 4py. So that p is very important in a parabola. We want to solve that first. So 4p equals 8 because of the 8y here. So p equals positive 2. And we will use that later on to identify or to locate where is the focus and also the directrix of this parabola. But first, let's locate the vertex. That's the hk. You can clearly see here that the vertex is at 0, 0. And then we have this imaginary line that divides the parabola into two equal parts. We call that the axis of symmetry. So for the axis of symmetry, the equation of that depends on your h. So if h is equal to 0 in this case, that means our axis of symmetry is at x equals 0. Now let's go on the focus. So the focus is basically located, in this case, it's obviously above the vertex, and the distance of that is going to be depends on the p value. So p is 2, so that means 2 units above the vertex. So that means it's somewhere here. Generally speaking, we can find the focus or the coordinates of the focus by having this formula. So you have the h, which in this case it is 0, k plus p. Our k here is 0, and our p is positive 2. So here we have 0 plus 2. So that means our p is equal, our x coordinate of the focus is equal to 2. And then, of course, on the other side of that, we have the directrix, and that's here down on the downside of the vertex. The equation of that, or in order for us to find the equation of the directrix, that's y equals k minus p. So k is equal to 0, and then our p is 2. So that's just 0 minus 2, which is equal to negative 2. So y equals negative 2. That's our directrix. And maybe you already know this, that the distance of the vertex to the focus is equal to the absolute value of p. In this case, it's 2. That's equal to the distance of the vertex to the directrix. And again, that's the absolute value of p, which again is 2. And then lastly, or second to the last thing that I need to mention here is are the ends of the latus rectum, or the LR. So let's start first with the ones on the left side. That's this point, the purple circle that you're seeing right now. So if we use the formula, is h minus 2p. So h is 0, p is 2, so that is 0 minus 2 times 2, which is equal to negative 4. And then we have the k plus p, which is the same as the y coordinate of the focus. Okay, and that now we have a negative 4 and 2. And then the right end, we have this one. So for the h, the formula of that is h plus 2p this time. So 0 plus 2 times 2, which is equal to 4. And again, the y coordinate is the same as the y coordinate of the focus. And then lastly here that I want you to remember is the distance of those two endpoints of our LR, or the lattice rectum. So that's equal to the absolute value of 4p, and we can actually clearly see that from the equation, and that equals 8. Okay, now what if our hk is outside the origin, or not in the origin? Okay, so for example, in this parabola, okay, let's see. Alright, again, this parabola is being represented by the equation x plus 3 squared equals 6 times y minus 2. Generally speaking, we have x minus h squared equals 4p times y minus k. You see the ones on the left side, that's going to tell you whether the parabola opens upward, vertically, or sidewards. So here we have an x minus h, or x plus 3 squared, that means it can either opens upward or downward. In this case, it's upward because if you look at the right side, it's positive. And our p here is going to be greater than 0. So to solve for p, we have 4p equals 6. Okay, so you can clearly here see the 6. So that's 4p equals 6. That means p is equal to 1.5. So that's 6 divided by 4. You can express that as a fraction if you want. All right, let's identify the vertex. That's this one. We can also see that from the equation. That's negative 3 and positive 2. All right, that's hk. And then we have this imaginary line that divides the parabola into two equal parts. That's the value of our h, axis of symmetry. We call that it opens upward, and whatever the value of our h, that is our equation of the axis of symmetry. Now let's locate where is the focus. Again, the focus, the distance of the focus from the vertex is equal to the absolute value of p. So here our p is 1.5, so that means the focus is somewhere here. Now if you use the formula, that will be h, which is negative 3, k plus p. K is 2 plus 1.5, and that will be 3.5, right? So that will be the coordinates of our focus. Now, the other thing that, again, we need to remember is the directrix. So the location of that is under the vertex if the parabola is if the parabola opens upward. So here the formula for the directrix is equal to y equals k minus p. K is equal to positive 2. P is 1.5. So 2 minus 1.5 is equal to 0.5, or 1/2. Okay, so again, I want to emphasize this. The distance of the vertex to the focus and the distance of the vertex to the directrix are the distances are equal, and it's equal to the absolute value of p, which in this case is 1.5. Now let's locate the ends of our LR, or lattice rectum. The left side, we have this formula in order for us to find the vertex of that. That's h minus 2p and k plus p. So h in this case is negative 3, right? It's negative 3 minus 2 times 1.5. So 2 times 1.5 is equal to 2 times 1.5 is equal to 3. So negative 3 minus 3 is equal to negative 6. So let me just write that down. Negative 3 minus, 2 times 1.5. There you go. That's going to give us negative 6. And then for the y coordinate, that's the same as the y coordinate of our focus, which is at 3.5, k plus p. Now the other end, we have this, and then this is the formula for that one. If on the left end we have h minus 2p, the right end is h plus 2p. Okay, and then of course the y coordinate is going to be the same as the y coordinate of our focus. So h is negative 3 plus 2 times 2 times p is 1.5. So that will be equal to 0, right? Okay, so 0 and 3.5. And of course, again, I want to emphasize this. I'm going to connect those two ends of LR, or lattice rectum. The length of that is, guess what? That is correct. Yeah, that's just, we can clearly see that from the equation. That is equal to 6, absolute value of our 4p, and that equals 6.